Well, there's been a lot of talk, of AI spending this earnings season, with data centers being a huge contributor to capital expenditure forecasts. Data center market has more than doubled since 2022 to over $27 billion last year. And by 2027, it's projected to surpass $41 billion.
Data centers are actually growing at an unprecedented pace. In 2022, they accounted for about 1 to 2% of the total global electricity use. It's expected to almost double by 2027.
So it's quite lucrative for us. The race for AI is still on, and we can't build them fast enough. What we need is land and power.
Amanda Peterson-Corio wanted us to see these whirling fans. They're cooling these endless rows of servers and miles of cable, the arteries of the internet inside a Google data center.
It's hard to imagine that there is a physical location where the internet lives, but this is it.
Every click, every hit of I agree, every social media account, interaction, message, it all adds up to a lot of data, and that's where we're going. With the rise of all these new technologies, according to The Verge, some data centers used by Google, Facebook, and Amazon use more electricity in a single center than the entire country of Ireland. But it's not just how big they are, it's how essential they are for our lives on a day-to-day basis. Everything's now running with electricity, and all that electricity is utilized for data. Whether you take a flight, get in a taxi, or you're just starting that new course, all of that data needs to be stored somewhere. So how did we get here? How did we go from some of these old computers you see behind me to the massive data centers and farms that you see across the world? This is exactly what our team wanted to research, and we wanted to not only see where we came from, but where we're going next. So to find out what this landscape looks like in terms of data centers currently, where we came from and where we're headed, we sat down with some of the top researchers, consultants, and engineers all across different industries. In the early days, storing data meant huge machines in loud rooms with lots of people running around. You needed a lot of patience. Magnetic tapes, punch cards, and mainframes were the main source of data storage at this time.
Because the problem is on the old plastic tapes that we used to use, they simply degraded over time. Like the material themselves, the old hard drives, the same problem, right? The magnetic film they put on the glass discs, they degrade. And so left alone in the old physical days, right, the devices don't spin anymore.
This transition from old to newer technologies was the main debate we wanted to tackle in the scape of data centers. Specifically, our team wanted to look at tape storage, how it was maybe phased out throughout the years, but what we found was a very different story. To understand the evolution and maybe the withdrawal of different data center technologies, we sat down with professional Chuck P. Williams.
I originally started my career at a large Canadian retailer, a company called Sears Canada, and I started out there as a programmer, working on various business applications. And eventually I was transferred over to the infrastructure side of the business, and I worked in the data center environment. So I managed a number of different teams over the years that specialized in data center operations, tape operations, disaster recovery, business continuity, things like that. After several years in different management roles, I moved into the strategic sourcing group for technology. So I was purchasing, procurement, buying the technology, buying tape libraries, buying mainframes, buying servers, that kind of thing. When I first joined Sears and I was observing in the data center, the tape operators wore skates. They wore like inline skates, and they were on a raised floor. And what they would do is they would skate to the library, which were racks, movable racks. They would skate to the rack. They would grab a cartridge, like they had a console. The console would say, somebody wants tape T0785. They're waiting. Hurry, hurry. And the operator would see this number, and they would have a little application, like a library, and they would say the T05s, that's in aisle 7, section G. And they would skate down there. They would grab the cartridge. They would skate back, and they would put it in a single tape drive. But eventually, the data became so prolific that the amount of tapes and the amount of operators became so crazy that they were bumping into each other. They were smacking into each other as they skated around the floor to try to get to the cartridge. Tapes have never disappeared. They've always been there. Depends on the use case. What does the businesses need to store data? Is it a convenience thing? Do you want to store your data in case of something happening? Is it a compliance thing? The law says you must do this. Is it a smart thing? In other words, if your business is dependent on data and you lose your data, you're out of business. So therefore, don't lose it, right? Do everything you can to take that data and protect it, right? This is the whole science behind, disaster recovery and business continuity. And so by backing your data up onto physical tape, the hackers can't necessarily get to it. If you take the tape, lift it out of the machine, put it in a box, drive it away to another facility, go down into the basement, put that box on a shelf and lock the door, that data has been air gapped against any sort of attack vector from a threat outside. So again, depending on your strategy for security, depending on your strategy for business continuity, this is why tapes continue to have a role in most technology, businesses. The LTO Ultrium Consortium has been forecasting their future generations for the last, 20 years. They've got all their generations of their forecasted tape. And I think we're at generation, I'm going to say 8 or 9 today. But if you look at the chart, it actually probably goes to 13 or 14 or even 15 generations out. And we're only at generation 9. And if you look at that, you'll see generation 9 says something like, our tapes will give you 15 terabytes of uncompressed storage and maybe 30 compressed. But generation 15 or 14, it's going to be like 200 terabytes uncompressed and 400 terabytes compressed. That's our goal. That's where we're heading.
As Chuck pointed out, while the data center landscape has changed drastically over the years, one thing that's persisted is the need for tape storage.
So back in the days, storage was expensive, slow, and physical. A single gigabyte could cost thousands of dollars. Today, you can fit 1,000 gigabytes, a terabyte maybe, just in your pocket, on your iPhone or Android, or even your smartwatch. But the needs of businesses were growing. As researchers collected more data and businesses had more customers with new consumer data, the new data storage systems were built to retrieve it and utilize it effectively. A really interesting example of this comes from the world of particle research physics. You might know CERN as the place where the Large Hadron Collider accelerates hadrons and different particles at near the speed of light together. But what you might not know is these experiments produce more data than any other experiments in the world. And this is one of the reasons why the World Wide Web was actually invented at CERN by a scientist who wanted to connect fellow researchers. It's for this reason we sat down with CTO of CERN Open Lab and the head of CERN Computing, Luca Azzori.
So tape, I would say very little is not true, but it's a bit marginal, but I'll get to it. So my main duty is to work on procurement of hardware for the data center. And tied to that, there is also the capacity planning of basically understanding what will be the needs, the computing needs of the organization, and make sure that we are always able to fulfill them. Now, my field of specialization historically for education and technical reasons, it's on computing, actually, not on storage. But of course, I'm also in charge of procuring storage devices. I'm not directly, let's say, in charge of procuring tape storage. There's a dedicated team for that. But as I said, because of the capacity planning, this has an impact, as a repercussion. So I have to take this into account. And I'm anyway in charge of procuring all the servers that you need to operate the tape libraries. So that's a very, very summarized description of what I do, what I take care of. But we are more, I would say, high throughput science. So we produce very large amounts of data. I think we reached recently 1 exabyte of data in spinning storage. CERN aims to basically keep as long as possible, ideally forever, every data, every experimental physics data that has been produced by our accelerators, by our experiments. This is simply because there's still value in potentially analyzing all the experimental data that was produced some time ago. Like we even have data that is produced during the LEP era, which is the accelerator that preceded LHC. The reason of putting tape is simply because there's no better technology, or let's say there's no better commercial off-the-shelf technology that can be used to achieve that at a reasonable cost. Of course, one could always use hard drives, either spinning or flash, but imagine, keeping that running for decades, you will always need to copy back and forth. The hard drives have a certain lifetime, and it will be much more costly. So basically, the experts decided or realized that the cheapest way was to use tape. And then, yeah, I mean, in my lifetime at CERN, most likely the two main things that had a huge impact are the massive availability of flash storage compared to the past. It's much more cheap, much more affordable now. And on strictly speaking in computing, the advent of GPUs, although I have to say that CERN relies on them in production, but is still not the central bulk of our computation. It's we are still very much a CPU-oriented calculation entity. Now, focusing a bit more on storage, so yeah, I will say flash has probably been the main game changer in the past 15 years or something. And more we are seeing its adoption, first of all, in the computing servers or in servers in general. We definitely do not put, since many years, spinning drives. Everything inside the server is storage. One is Open Lab, which aims through the mechanism of public-private collaborations, for example, with the leading IT companies or other research institutes, to probe and to investigate future technologies that will shape our future infrastructure. So it's not really just a mid-term or short-term decision, but it's really, okay, let's explore this very future-looking technology that is a bit even exotic at the moment, and who knows, maybe in 10 years, 5 years will be relevant. Instead, for the much more immediate deployment of equipment, we are simply based on market analysis, what are the current market trends from the main manufacturers. So for CPUs, as you can guess, is the x86 and the ARM world, or for storage is spinning, flash. So quite, let's say, standard technologies.
But it's not just scientific researchers and big projects like CERN that need to store their data somewhere. It's everyday people like you and me. Whether it's our photos, our financial data, we all have to put it somewhere. And normally that's on someone else's computer in what we like to call the cloud.
Because we understood out of the gate, the cloud, public cloud business is not cheaper. If you have your own data center, it's expensive, but it's not nearly as expensive as having to rent the compute power from a cloud provider, okay? The reason you go to a cloud provider is because it takes about 10 minutes to deploy a new server. You want to deploy 100 servers, you can do it in 30 minutes. You want to add 256 gig of RAM to 250 servers, like you can do that in half an hour. You know what I mean? Everything just becomes so incredibly fluid. It's hard to resist it. Now, it's expensive because guess what, Nathan? You push the wrong button, all of a sudden you've deployed 500 servers. Oops, I meant a 50. I put 500 in. You hit the execute button. All of a sudden you got 500 servers created, and the cloud is a real-time business, right? So as soon as these things come to life, the meter starts running.
So to understand how banks and financial institutions deal with this sensitive data, we sat down with Phil Moran, a managing director at Lexington Innovations, who deals with this sort of sensitive data all the time.
I'm Phil Moran. I've been in technology I guess I built my first computer in 1977. And I started my programming in punch cards and optical cards, and have moved all the way through to microservices. And most of that work has been in the capital market space, so banking, capital markets. And I've worked here. I spent a bunch of years on Wall Street doing work there. Some cool technologies, others that have long since been retired because they've just been supplanted. We knew more, things got better. It was worse than that. It was desktop publishing. And it was a $1 trillion a day business. And they were running it source code on the production servers, not compiled. And no concept of source code storage or versioning. You would change the source code right on the server. And you could break out of it running pricing models, fix something, and then tell it to continue the processing, because you could just break it in the middle of a piece of code and it would start again. And it's what you called in those days, it was the Wild West. It's sort of the dirty little secret in banking and capital markets that it's highly secure, because it isn't, which is why I keep hearing of all these breaches. Part of the problem is that banks aren't a cohesive sort of small finite set of applications that are in concert with each other. They are thousands of bullshitty little apps and batch files and spreadsheets, and they just get modified here and there, and they get sent into data warehouses, and then somebody else aggregates them from multiple data warehouses and produces a report for them. And so there is just at how they work overall, it's very hard for them to truly be secure. You now have to know by product type and lifetime of the transaction which ones need to be stored long term versus those that can last only 7 years, because the new rule came out that it's 7 years after settlement, or after maturity. Once the deal is matured, 7 years, then you can delete it. A 30-year trade now has to be around for 37 years. And what was the bank's answer? Very typical for the bank. We're storing everything for the longest trade we've got. And what I tried to, at this particular bank, I tried to talk to them. It's like, well, now you're storing everything forever, and that's not going to work.
But with all this sensitive data, there needs to be regulation. That's why governments in recent years have been putting different restrictions and regulations on companies storing your data.
You got to keep anything important for 7 years. It's an audit requirement. This is a generic reference to the fact that the government of Canada, and probably the government of the US as well, requires that businesses maintain crucial business information and data for a period of 7 years in the event the government wants to come back and validate that you told the truth when you filed your taxes, when you did this, when you did that. And so companies have to bear that proof. In the olden days, it was a box and there were papers stuck in it.
The data sovereignty is critical issue, right? Because in the U.S., data that sits in the U.S., the U.S. government has rights to get at. And so Canadian banks don't necessarily want that, right? And other companies don't either. It also makes you eligible for their regulatory requirements. So there's that part of it. And then there's simply the security that is, well, if my data is just somewhere in Amazon cloud, how do I know that Amazon doesn't have access to it, that my rival bank is on the same machine? So you'll end up going to private cloud. You'll go to segregated machines, which is really the same thing. So they'll make large deals with people like Google, and they'll say, look, we're going to buy 1,000 servers from you, and they're going to be segregated. They're going to be on their own network. They're going to be, they're completely encrypted, and all of the connections have to go to some small set of IPs that we control. And then it's really all they've done is it's not cloud computing as we kind of understand it. They've really just outsourced the running of their hardware to Amazon or somebody else.
To understand more about these regulations, we sat down with Yusuf Gisous, data consultant and governance managing partner at PwC.
Evolution is that right now the data in Microsoft SharePoint are more structured because we have all the compliance rules that we have to be compliant to, and therefore we have to gather all the metadata regarding this, see what do we collect and when it should be removed, depending on what's inside. If, for example, it contains personal data, it shouldn't stay more than X years XTEL. Yeah, they are different depending on the level of security needed by the company. For example, in insurance company, all the data regarding personal people is highly regarded. So you have to make sure that it's stored the right way and it's conserved the right way. Therefore, the rules are way more strict there than in other companies where sometimes you don't even have personal data. But most of the times, you have to set up a good governance to be able to store data the right way, and most of the companies aren't in that maturity yet to be able to have the right governance for each type of storage. If you see on a larger scale, there are many companies who are still struggling with putting up the right governance of data, like the roles and how they should interact between them. And this is way before you put the storage rules, for example.
You might not think about your data much. In fact, it might even be invisible to you, but it's one of the most important things in today's day and age. Whether it's just your photos, videos, it all has to be stored somewhere, likely in a large data center held by one of the most complicated or complex companies in the world like Google, Facebook, or Amazon. But we came a long way. Data storage used to be physical tapes in some building, maybe even grabbed by people on roller skates. But we've seen how this evolved and needs a lot of government regulation and needs to be held accountable to make sure your data is stored securely and used for the right purposes.
And there's a big distinction when you look at how to manage data. It's expensive to hold it. It's expensive to protect it. But it's the most important thing. These are your gold nuggets in a business. The data is the thing. They talk about data is the new oil. That's what they mean. Mm-hmm. It's so important. If a company loses its data, it's nothing.
The rise of new technology like AI, the demands for data storage are just going to increase exponentially. In the coming years, new technology is just going to be producing more data that can have data bias and can be utilized for bad actors both globally and locally. So it's important and vital even to understand how to secure this data and how to utilize it properly. That's why we wanted to do this project and understand how the past can shape the future of data storage and how it can be used in an ethical manner.
We wanted to take a quick second to thank our amazing interviewees who made this project possible. They not only shared insights around the debates surrounding data storage technology over the years, including the evolution from simple matters of physical hardware into cloud infrastructure, but they shared it across many different fields, offering many different perspectives.